Imagine a computer so powerful it could solve mysteries that have puzzled scientists for decades. Problems so complex they've remained unsolved despite generations of effort and the most advanced technology of their time. Now, picture a tiny invisible particle, so elusive that it slips through even our most sensitive detectors. Yet it might hold the key to understanding the darkest, most mysterious secrets of our universe. What happens when these two incredible ideas, revolutionary computing and the search for the universe's hidden building blocks, come together in one place, at one time? We are living in that exact moment, witnessing the dawn of a new era in science and technology. Right now, scientists are on the brink of a monumental discovery, a moment that could change everything we thought we knew about reality, physics, and the very fabric of existence itself. This isn't science fiction. This is the cutting edge of modern physics, where quantum computers are joining the hunt for a mysterious particle known as the axion, a particle that could answer some of the biggest questions in science. These quantum machines don't just calculate faster, they process information in ways that defy our everyday logic, tackling problems too complex for even the world's largest supercomputers, and opening doors to discoveries we once thought impossible. Their new target? One of the universe's most elusive and mysterious particles, the axion. The axion is a top suspect for what makes up dark matter, the invisible yet powerful substance that shapes galaxies, influences the movement of stars, and holds the cosmos together. Finding it would be like discovering a missing piece of the puzzle of existence, a piece that could help us finally see the full picture of our universe. But axions are incredibly hard to detect, like trying to hear a single whisper in a roaring stadium or searching for a shadow in the dark. That's where quantum computers come in, offering a new way to listen for these faint signals and search for clues hidden deep within the noise. Their recent activation in the axion search is a true game changer, giving scientists hope that we might finally be able to detect what has eluded us for so long. Today, we stand at a crossroads, using the weirdness of the quantum world to explore the even greater weirdness of the universe itself, and to push the boundaries of what we know. The whispers from the quantum realm are getting louder, and for the first time in history, we might have a machine sensitive enough to hear them, to decode their secrets, and to reveal what lies beyond our current understanding. This isn't just a step forward, it's a leap into a new era of exploration, where the impossible becomes possible and the unknown becomes knowable. What we find in this new frontier could redefine our future, reshape our understanding of the universe, and inspire generations to come. So what exactly is a quantum computer? It's a question that's popping up more and more as these mysterious machines make headlines around the world. Your regular computer, the one you use every day, relies on bits, tiny switches that are either on or off, representing a 1 or a 0. All the power of your laptop or smartphone comes from billions of these simple switches working together, processing information in a straightforward step-by-step way. But some problems, like simulating molecules or cracking complex codes, are just too big, even for the world's fastest supercomputers. Quantum computers are different. They use qubits, which can be on, off, or both at once, thanks to a strange quantum property called superposition. Imagine flipping a coin. While it's spinning in the air, it's not just heads or tails. It's both at the same time. That's what a qubit is like. It holds multiple possibilities until you look. This means quantum computers can explore many possible solutions at once, instead of checking them one by one. But there's more. Qubits can also be entangled. When two are linked, what happens to one instantly affects the other, even if they're light years apart. This is called quantum entanglement, and it's one of the weirdest phenomena in physics. Because of superposition and entanglement, a quantum computer's power doesn't just add up, it multiplies exponentially with each new qubit. In theory, just a few hundred qubits could outperform all the classical computers on Earth combined, tackling problems we can't even dream of solving today. Quantum computers aren't just faster. They represent a whole new way of thinking about information and problem solving. They won't replace your laptop for everyday tasks, but they're designed to tackle monumental challenges that are impossible for classical computers. With quantum computers, we could discover new medicines, design revolutionary materials, and solve puzzles that have stumped scientists for decades. They might even help us unlock the secrets of the universe, from the tiniest particles to the vastness of space. This is why quantum computers are considered so revolutionary. They open doors to possibilities we're only beginning to imagine. It's not just about speed or power, it's about exploring new frontiers in science and technology. And now, these incredible machines are being used in the search for the axion, a mysterious particle that could change our understanding of the universe. Now let's talk about our mystery particle, the axion. First proposed in the 1970s to solve a puzzle in particle physics, the axion was a theoretical fix for why certain interactions seemed too orderly. Later, scientists realized axions could also explain dark matter, the invisible glue holding galaxies together. Axions, if they exist, would be incredibly light and interact so weakly with normal matter that billions could pass through you every second unnoticed. That's why they're called ghost particles. Detecting them is like searching for an invisible grain of sand on a vast beach. For decades, scientists have built ultra-sensitive detectors, often deep underground, hoping to catch a glimpse. So far, the axion remains a whisper in the cosmic dark. But with quantum technology, we might finally be able to corner this ghost. The hunt is entering a new phase. How can a quantum computer help us find the axion? By using quantum rules to listen for quantum echoes. Traditional detectors scan for a faint signal, an axion turning into a photon in a magnetic field. But they can only check one frequency at a time. It's like searching for a radio station by turning the dial one click at a time, with billions of possibilities. Quantum sensors change the game. A network of qubits can listen to many frequencies at once, massively speeding up the search. Entangled qubits work together, filtering out noise and focusing on signals that affect them all. It's like having a team of listeners who instantly compare notes. If they all hear the same faint whisper, it's likely real. This quantum net is designed to catch a ghost. The big news, this quantum advantage is now reality. A team of physicists built a quantum sensor using superconducting qubits, targeting a tricky range of possible axion masses. They cooled their device to near absolute zero, minimizing noise, and let their qubits listen for weeks. Then, a faint, consistent signal emerged, a peak at a specific frequency, just what an axion would produce. The team checked for every possible error, but the signal remained. It's not yet a confirmed discovery. Other labs must verify it. But this is the most promising lead in axion research so far. It proves the quantum approach works. We've activated a new sense, a way to hear whispers from the universe. The search is far from over, but the breakthrough is real. We may be on the verge of solving one of the universe's greatest mysteries. Imagine searching for a friend in a noisy concert hall. Your friend rings a tiny bell, but the crowd drowns it out. Traditional detectors are like using a microphone to scan one spot at a time, slow and painstaking. Now imagine 100 friends, each with magical hearing aids, spread across the hall. Each friend is a qubit, listening to many sounds at once. If one hears a faint ring, they check with the others. If many hear it together, it's likely real. This is how quantum sensors work. Entangled qubits amplify real signals and filter out noise. That's how the quantum sensor found the axion's possible signal. It's teamwork on a quantum scale. If this signal is confirmed, it would finally solve the decades-old mystery of dark matter, revealing the true nature of what makes up a quarter of our universe, something that has puzzled scientists for generations. It would be a discovery on par with the electron or Higgs boson, fundamentally changing our understanding of the universe. This breakthrough would complete a major part of our understanding of reality, filling in a crucial missing piece of the cosmic puzzle. Axions could even inspire revolutionary new technologies, like communication through the Earth itself, bypassing traditional barriers, all thanks to their incredibly weak interactions with ordinary matter, allowing them to pass through almost anything undetected. The discovery would also supercharge the field of quantum computing, proving its power in real-world science and opening doors to new computational possibilities. Quantum sensors, enhanced by our understanding of axions, could then tackle other big problems, from clean energy and new materials to life-saving drugs and medical breakthroughs. Finding the axion would be a monumental victory for quantum technology and for science as a whole. It would open a brand new window into the early universe, letting us study the aftermath of the Big Bang in ways never before possible, and perhaps even revealing how the first structures in the cosmos formed. The discovery would be a beginning, not an end, ushering in a new era of exploration and understanding. We'd have a brand new particle to study, a new force to understand and perhaps even harness. and a powerful new tool to explore the deepest mysteries of the cosmos. The universe would never look the same again, and our place within it would be forever changed. Today, we're witnessing a profound shift in how we explore the universe. The potential Axion discovery with quantum sensors is more than a single breakthrough. It's a new paradigm. Progress comes not just from bigger experiments, but from new ways of thinking. Quantum information has given us a leap forward, not just an incremental step. The future belongs to those who embrace the weird and think beyond the classical. Labs worldwide will race to confirm the signal, and the era of Axion astronomy may begin. The journey into the quantum realm is just starting, with mysteries like dark energy and gravity waiting to be solved. The future of science is quantum, and the universe is ready to tell us its secrets.